Howdy everyone, howdy Dr. Ackerman and my classmate in Statistics 653. Today I would like to present my findings as well as some discoveries for my semester project, and the title of my project today is Detergent Sales Investigation. First, as an overview of the project, I will talk about the background of the project that includes the objective of the project as well as the data source for my project. I will then continue with the project description that includes the independent variables as well as the response variable and the methodology and approaches to my project. I will then discuss the result analysis that talk about the Poisson distribution of the data sets and the result from fitting the model for two attempts. Attempt 1 is without the overdispersion problem, and attempt 2 takes the overdispersion problem into account. And then I would finally conclude the presentation. First, this project objectives include to examine the current issue in sales and marketing, specifically in the industry of detergent, to study the effect of promotion and price on the sales obtained, to apply statistical methods to the fields of interest, specifically to apply the generalized linear mix model with a random effect. The data source is from a professor of marketing from Mays Business School, Professor Ram Kumar Janakiraman, who is an assistant professor of Mays Business School Department of Marketing, and he specializes in quantitative marketing as well as modeling. So he has a lot of data sets that he uses for his research, and he's provided me with one of his detergent data sets for my project. As a project description, I identify my problem of interest as the detergent sales data in order to study the effects of promotion and price on the sales of the detergent. And certainly, the response variable in this case is the number of detergent sales. And because the detergent sales are recorded by packages of detergents that are sold through a number of weeks, so these data are discrete and could be considered Poisson distribution. Among the independent variables, there are brands, and in independent variables of brands, I have Tide, Whisk, Era, and Surf. And these 4 brands are randomly chosen among the brands of detergent within the nation. So these can be considered the random effects for the model. The second variable is the promotion, and I have 2 levels of this factor. I coded the presence of the promotion as 1 and the lack of promotion as 0. And because these are the only types of promotion that we're investigating, so this is a fixed effect. And then I have a column for the price, which is a continuous variable, so it can be considered covariate in this model. The method I'm using in this project to determine the effect of brands and promotion and price on the sales is the generalized linear mix model, and I'm using the ProgLimix InSAT software for the Poisson distribution. So here in the model specification, I have the log. Because of the Poisson distribution, I have the log of the mu of detergent sales over the gamma equals the intercept plus the fixed effect plus the random effect with the covariate price and the random error term. Here's how the data set looks. I have 56 observations in the data set, 14 observations for each of the 4 brands, Tide, Whisk, Era, and Surf. And I have, in each brand, I have 14 observations. 7 observations are for the promotion campaign, the campaign without the promotion. And 7 observations for the campaign with the promotion. And then the covariate variable here is price with continuous variable. And then the sales figure for the number of detergents sold. First, in the first part of a project, I examined the Poisson distribution, so I used the univariate procedure. I specified the data as cells for the data sets of detergent cells. I specified the variables as cells. I asked for the histogram and the probability plot, and then I ran the coding. And according to the results obtained, there are 56 observations. The variance is a lot larger and greater than the mean, so there's a potential for overdispersion problem. And the skewness indicated by the result output is positive, indicating that the data is rightly skewed. And then looking at the location test for Poisson distribution, I could see that the p-values is very small, a lot less than 0.0001. So I reject the null. The null is that the data is not for Poisson distribution, and I reject the null. So Poisson distribution in this case is significant. And I also did examine the goodness of fit test for normality. And the null in this case is that the data is from normality distribution. And the p-value is less than 0.01, so I reject the null. So I could conclude that the data is not from normality distribution, and instead are from Poisson distribution, and the Poisson distribution in this case is significant. This is the distribution graph for the univariate procedure output, and we could see that in this graph the data are not very symmetric and is more skewed to the right. So we could see the Poisson distribution in this case. As well as the probability plot for the cells, we could see that this curve here indicates the Poisson distribution, and there's the potential for the outliers as well as the over-dispersion problem. We see from these observations over here. Now, in order to fit the generalized linear mix model, there are two attempts to fit the Poisson distribution. In attempt number 1, I neglect the over-dispersion problem. So I indicate the procedure coding as the Glimix procedure that I have data as cells, the classification variables at brand and promotion, because these variables are categorical, and the model statement includes the cells equal to promotion and price. And I have the fixed effects in the model statement and the covariate in the model statement. I ask for the distribution as Poisson, and I ask for the link function because the Poisson distribution requires the log, and I ask for the solution. In a random statement, I include the brand because the brand is a random effect, and then I ask for the output with the prediction as well as the Pearson prediction, and I ran the procedure. And after running the procedure, the result output indicated here. Among the result output, we could see that the effects of promotion and price are significant. And from the solution for the fixed effect model, we could see that the estimated parameter for the promotion 0 and promotion 0 and promotion 1, and we could see the parameter for the price. So from these estimations, the model specification for the campaign without the promotion, so this is without the promotion, as log of mu of cells over gamma equals 5.5, and this number is the sum of these two numbers because we have the intercept and we have the promotion effect, minus 0.3 times price plus the random error term, and minus 0.3085 is from the estimated covariate price that we have over here. And then because the brand effect is a random effect, so we receive the brand-to-brand variation over here in the covariance parameter estimates as 0.7921. And then, as mentioned before, the effects of promotion and price are significant because the p-value is very small in this case. In attempt number 2, I took over-dispersion problem into account, and the coding for the procedure in the SAS software is pretty much the same as the procedure in attempt number 1, except that I include the random statement with the residual variation in this coding. All other statements are pretty much the same. I asked for the output as well as the Pearson predictions, and then I ran the model, and this coding takes the over-dispersion problem into consideration. The output that shows here is a little bit different from the output that was shown in attempt number 1. In this case, the effects of promotion and price are a lot less significant because we can see the p-value for the effect of promotion and price here are a lot larger than the p-values that we receive from attempt number 1. This is the effect for the promotion and price that we have over here. Also, for for the estimation of the parameter for promotion price, we can specify the model fit for promotion without the campaign. We have the log of the mean of the sales of the detergent over the gamma equal 5.5734, and this number is the sum of these two numbers because we have the intercept and we have the effect of promotion, which is a fixed effect categorical, minus 0.3085, because we have covariance of price over here times price, and then we have the random error term. The difference in this case from attempt number 1 is that we have the brand-to-brand variation indicated in the covariance parameter estimates model over here, and we also have the residual variation. We have the brand-to-brand variation as 0.7807, and we have the residual variation as 131.734, and this number is rather large. That indicates the potential for over-dispersion problem as well as the outliers in the data sets. And then, as mentioned above, the effects of promotion and price are a lot less significant, and in this case, if we are 95% confident, we can see that promotion and price are no longer significant in this case. In conclusion, there is an over-dispersion problem present in the data, and this over-dispersion problem could possibly be due to the seasonality of the product sales, because the data are recorded specifically from week to week. And also, if we take into account the seasonality that could cause over-dispersion problem, we could see that the fixed effects as the promotion and price become less significant because the random error and the residual play a more important role in this case. And with that, I would like to make some implication for the general detergent sales issues in the country. First, the higher price may lead to a decrease in sales, as we could see from attempt number 1, which didn't take over-dispersion problem into consideration. The presence of promotion could offset, and in this case, it could compensate for a decrease in sales due to an increase in prices. And as mentioned before, the seasonality is an important factor in the sales. And with that, I would like to conclude my presentation for the project, and thank you for listening.